step 5, what I'm doing is I'm guaranteeing you should never get i's, right? So why, I don't know if I'm making any sense here. Look, this is just so, look, if you don't have any x-intercepts, why would you ever go try and find them? You know what I'm saying? Like, why waste the time of trying to solve a quadratic equation if there aren't x-intercepts to begin with? So it's just a time-saving thing in here. I know that I should get 2 answers from this, right? I should not see an I. If I see an I messed up. All right, so how would you like to solve that quadratic? You could use the formula, right? The quadratic formula, because we have all 3 things are there, right? We have x squared, x, and a constant. I could go to that, or if I didn't want to do that, maybe it factors. And it does. I made this one so it factored since it was our first problem. See how that factors? Now look, if you have fallen in love with this formula, all right, then you may use it all the time. But I factor when I can factor. And what was the point of factoring that? What do if I can factor left side, I do what at the next step? So, yes, but how? I have set each factor equal to 0. Good. So I'm going to set the first factor equal to 0 and set the second factor equal to 0. And now those are 2 little miniature linear equations that you just solve for x. So I just like add 5 to both sides here. And then here I subtract 1. And I'm happy. Happy. I assure you that was faster than using the quadratic formula. We good? Okay. Next step, the y-intercept. And I should only have 1. So step 6, y-intercept. How do you find the y-intercept? Set x equal to 0. Set x equal to 0, solve for y.
How would you do that if you use quadratic formula?
For the y-intercept?
Maybe the same, you use quadratic formula.
Wait, are we talking about this or are you talking about this?
Oh, for the y.
For the y, you would never use a quadratic formula because for the quadratic formula, what you've done is you've replaced the y with 0. To get the y-intercepts, we don't replace y with 0, we replace x with 0. This is actually very easy to do computation-wise, because if you go over to your equation over here, right? Step 6. If I come in here and I set x equal to 0, then rewrite that. What would you get? Y is what? Well, that's 0, right? That's gone. That's gone. All you get is the constant, -5.
Oh.
And that's it. See? No formula necessary. Questions?
Do we write it y equals -5, or do we write it?
Yeah, that's what I was going to mention next. When I draw the pictures, when I'm going to write them as points. Okay, but you could leave it like that, or you could write them as points. The question is whether or not you can do that, or if you need to write it like this. Like that's a point, right? X was 0, y was -5. Either way. All right, now this is the last step. 7. Sketch. All right. So here comes the sketch. You're going to draw an x and y axes. This. X, y. And we're going to start drawing this by placing the vertex. So the vertex was at 2, -9, right? So I'm going to be a little more precise in my drawing here. I'm going to say like that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say that's 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's negative 10. My vertex is at 2, negative 9, which is somewhere around here. Now look, we just have to get like ballpark, okay? It doesn't have to be like perfect. You don't have to use graph paper, all right? We're not trying to put a man on the moon right now. We're just trying to get a picture of a parabola, all right? There's a vertex. Next, I'm going to put the X-intercepts. There were 2 of them. Where were they? And I'm going to label this too. 2, negative 9. What were my X-intercepts? 5 and negative 1. So 1, 2, 3, 4. Here's 5. Was right there. I'm going to label that point 5, 0. And then negative 1 was over here. I'm going to label that negative 1, 0. I also had a Y-intercept, right, of negative 5. So I'm going to come down and go 1, 2, 3, 4, 5, negative 5. So that's 0, negative 5. So do you see I have all the information written down? Everything, everything for the parabola that I found is here. I just need to draw it now. And when I draw it, I'm going to keep in mind this axis of symmetry. I'm going to use the axis of symmetry to help me draw it. Remember, if I draw a straight line through here, now this is not part of the graph, okay? So I'm going to make it dashed. I'm using a different color because I just want us to be aware that that's going to be used as a guide. Our picture that we draw should be a mirror image of itself over that line. And you can kind of tell, look, right here, the distance from here to here is the same as the distance from here to here, right? The X-intercepts are on like equally spaced on both sides. Do y'all see that? You can also kind of measure with your fingers like the distance from here to here. I should have another point over there like that same distance. So if you want to, you could just very loosely drop a dot over here to help you. And do you kind of see the shape of this thing? Yes? So I'm just going to draw a parabola in here. And keep in mind when you draw this, the bottom of this is U-shaped. It is not V-shaped. All right? I will take off for V-shaped parabolas. Absolute value functions are V's. Parabolas are U's. All right? So I start out with just a little smile, and then from there I draw the rest. And you just have to connect the dots here. We're back in kindergarten at this point. So we just connect that dot up like that, and then back through here, connect this up through here, and that is a rough sketch of the parabola. Understand? Now this was a fairly simple parabola because a lot of things worked out in our favor. I'll point out what they were because we're not going to have enough time for anything else today because I blabbed too much about conquering castles. Okay? This is what we started with. I want us to keep in mind why this worked out so smoothly. When we did negative b over 2a, remember that? When we were finding h? It turned out to be 2, didn't it? I picked it very special so it would be a nice number. It could turn out that that's a decimal, or a fraction. And then your k is going to be ugly. Also, I made something that factored nicely, so our x-intercepts were nice numbers. So what we're going to get into next week is tackling parabolas that are a little more advanced than this, where the things are not as clean. Where when we try and find these x-intercepts, we can't factor it. We have to use a quadratic formula. And we're going to get those roots in there, and then we have to get our calculators out and approximate them. 1.5, like we did earlier, 1.5, negative 0.15. So this is just to kind of introduce us to the idea. We'll spend all of next class graphing. We'll do a couple of applications. For homework, what I think you're capable of doing is you finish the homework on page 63. 60, oh, did I assign 61? Okay, so go ahead and do page 63. This is going to be solving quadratic equations, all right? So you're going to be using quadratic formula on that homework. And then if you want to start graphing, I would maybe challenge you to do trying to look for one that factors. Page 69, just number 1 only. All right, so that's the homework. Everything on page 63, page 69, number 1 only. And have a great weekend. I will be out of town starting tonight, so I won't be on campus tomorrow, just in case. No one ever comes on Fridays to get help, but you know, it'll be that one Friday I decide I'm not here that, you know, 4 of you are going to show up. Hey, we're doing a study group.